All right, hi everybody. What I'm going to do is I'm going to solve this exponential equation, and this one has a little trick to it or something that makes it a little more difficult in that this exponential equation can be written as is a quadratic when we let u equal e to the x. So I don't know, there might be like saying it's a quadratic form, maybe would be the way to say it. But what happens, you let u equal e to the x. Now let me show you what's going on here. The first term I see is e to the 2x power. That is the same thing as e to the x squared. It's a property of exponents is that if you have e to the x parentheses squared, you multiply the exponents x and 2. And then I have minus e to the x minus 6 equals 0. Well, I'm saying let u equal e to the x, and I get u squared minus u minus 6 equals 0. And I hope this factors. I think it does. Negative 6 is equal to negative 3 plus 2, and negative 3 plus 2 is negative 1, so that's the factorization. I get u equals 3, u equals negative 2. Now, I go back, and what's u? U is e to the x. Well, the thing is that this guy here has no solution. And the reason is that the range, or the possible y values, when I have e to the x, are all positive numbers. The range is all positive numbers. E to x is never equal to negative 2. You could sketch the graph, or you can just think about it. How can you have e raised to a power to equal a negative? However, for this next part, so we're done with that. No solution on that one. For the next one, we solve e to the x equals 3, and we apply ln to both sides. So we get ln e to the x equals ln 3. This is equivalent to saying write as a logarithm. So I apply ln to both sides. Ln is the inverse of e to the x, and so an inverse function will cancel, and then I get this answer, x equals ln 3. It's my only answer. And there you go. So it's a little bit tricky, but it's also a little bit of an outlier of a problem. So I don't know if you'll see that many, say, when you take calculus, but I saw it in the book. I thought we'd go over it. Okay, that's all.